Okay, now I will create what is called the interaction plot. That is the plot that I mentioned where I had the profiles. R does not call them profiles, it calls them trace if you look up the documentation. So let's see what I am doing. I am writing with dat, so all the variables that I will be using, they are inside the file dat, and this first thing, tilt, is what they call the x variable, that is the variable that will be represented in the x-axis, and variety is the thing that will, so one type of variety will give rise to one line, another type of variety will give rise to another line, so R call it the trace variable, we call it the profile, and yield is the output whose average you will be taking. An interaction plot has many other arguments, so you can look up itself and learn about them. So let's try this. So I get this, so I have straight tilt at the x-axis, so I get these two, plane and slope in the x-axis, which is not a continuous axis, and variety is the thing for which I am creating my profile. So three varieties, they are given as continuous line, dashed and dot, Taichung Joy IR8, and I can see that they are just parallel. Of course, in a real life data situation, it may not be that parallel, but more or less parallel seems to imply that there is no interaction between these three things. So I can try this thing, fit yield tilde tilt plus variety dat equal to dat. I could have done the same thing here with dat, etc., but since LM will allow an argument called dat, so this dat is the name of the argument of LM, and this dat stands for the name of the variable. Coincidentally, I have used the same name dat as they have used for the parameter value. That's why this weird thing, dat equal to dat. So let's try that, and I will get a fit. So let's take a look at the fit. So I get these values, coefficient, intercept is given. Remember, the model is mu plus alpha I plus beta j. Now I have got two types of tilts, and the first one, so which will be dropped by R, that is, it will estimate that coefficient forcefully as 0, so it will not report that. So tilt plane has been forcefully made 0, tilt slope is estimated to be 6.64, so alpha 2 hat is 6.64, mu hat is 2.54, and similarly for the betas, beta 1 hat, which is variety IR8, that is suppressed, it has forcefully made 0, and beta 2 hat is 10.13 and beta 3 hat is 30.37. Now it will be an interesting exercise for you to try to do this. So what R did was that it fitted this model, so I will write it here, Yijk, so Yijk, do I have Ijk here? Yeah, I do have Ijk, Yijk, that is mu plus alpha I plus beta j plus epsilon ijk. So this is the model that I am fitting, and it is putting that extra constraint. Sometimes these are called identifiability constraints, because under these constraints the number of parameters effectively comes down, as Shourjyoti pointed out that I am having redundant parameter, and so R by default, R always will put this restriction, alpha 1 is equal to 0, beta 1 equal to 0. Now a more realistic explanation, a more realistic constraint would be this: you want to put summation of the alphas summation alpha I equal to 0 and summation beta j equal to 0. Under these restrictions, the estimates will be different. So my exercise would be to find out the estimate of mu alpha 1, alpha 2, beta 1, beta 2 and beta 3 under these constraints. So R is using this constraint. Use the output of R, no need to do everything from scratch, but somehow subtract certain quantities from these, compensate by adding it to some other place to find the estimates under these constraints. Now it will be a good idea to take a look at what is the estimated sigma square. It will report it as residual standard error is this 0.2495, that is sigma hat, square root of sigma square hat, and this 26 is n minus rank of x. You can try what is the rank of x, you understand it will be how much. Let's just try fit dollar rank, and rank is 4, that is the rank of x, and n is 30, so 30 minus 4 is rank of x. It's always a good idea to have an idea about the residuals. So I will try that. Fit dollar recede. If I just do this, the plot that I will get will be against the natural ordering, that is the way the cases were ordered, and it's a good idea to add a zero line, AB line, h equal to 0. So AB line will add a line, h equal to 0 means it has a horizontal line, add the value 0, and it will add to their existing plot. So this is the line, and this is nicely symmetrically arranged around 0, and I do not see any specific pattern, so I am happy with this, happy with the fit. Okay, so that's basically all that I wanted to say about fitting this model using R.